upper left square.
Here? That's our vertex.
Yeah, -1.
Jan, do you have something to add?
Wait,
Never mind.
yeah.
What I was shooting for, it's okay. That didn't come up. Malik, yep.
Access the symmetry.
Right. The vertex, remember, is at the very top or the very bottom. So I know that this vertex has to be on my axis of symmetry. You see that? Because remember, the vertex is the very top. When you're right at the very top or the bottom, it's symmetric on both sides. Okay, so one thing I use that for is I give her this 3, put it on the other side. I know that this y-intercept, the distance to get to the axis of symmetry, is going to be the same as getting to the other point on the other side. That's about right. So I would say just find that other point on the other side. Now you have 3 points. You can draw your parabola. And it's not going to be like a sharp point at the bottom. It has to be a rounded figure. It can't be a T, okay, or a triangle. Okay. So from these 4 steps, we were able to graph it. I probably just need to show one more example. We'll see how it works out from start to finish. And from there, we'll see how we feel about classwork. Isaac, you have a question?
Yeah, about the sharp point thing, it's unless the end values are spaced with only 1 square and the maximum or the minimum in the line of symmetry are far down or far up.
The only way we're going to end up with a graph that looks like this is if we're taking the graph of a square root. So we'll get to that in a moment, in a couple months. But for now, I want you to think of parabolas. They have the curve at that bottom. It's like an arch. So when you're just jotting them, they don't have to be perfect graphs, but I want to see that curve on the bottom. You'll get used to drawing those. Good input though. All right, we need to see one more of these. How about that? Yeah? But how's it clicking? Sideways, up or down? Thumbs up, sideways or down? Thumbs up, thumbs down? Oh, okay. Okay. Alternating. Sometimes I get it, sometimes I don't get it. All right, let's try one more together. We'll do this on the whiteboard here so we can graph right away.
Do we do one of the classes ones today?
Let's do it. Perfect. Good suggestion. Good suggestion. Why don't you read number 1 to me?
That's just on the practice here. Okay, f is x equals x squared plus 6x plus 5.
All right, this is number 1 for classwork, so this is helpful to everybody. Remember, classwork you can work on together, so everyone should get all your classwork points. All right, let's look at these different. 13.
Mark it.
All right, what are my A, B, and C? We can do this pretty straightforward and quick. What's my A?
X squared.
Actually, this was 1.
This is 1.
It's the coefficient in front of x squared. It's not a 0 there, it's a 1, because there's 1 of them. So this is my A, my B, 6, my C. All right, we just figured out so much just from that. So I look and think about the happy face, sad face. When A is positive, is it going to open up, happy face, or open down, sad face? A is positive?
Yeah.
It's positive, it's happy. That's one way to remember it. So we know that it does, it's going to look like that. It's going to be opening upward. Okay, we know from our step 4 behind here that my y-intercept is equal to which of these values? The y-intercept is equal to our c value. Y-intercept. Okay? That's quite a bit of information. We can actually start to put stuff on our graph. So I know that positive 5, 1, 2, 3, 4, 5. I know here at positive 5, I have a y-intercept because my c value is 5. Let's make this visible for everyone. All right, perfect. All right, now we just need to figure out where the vertex is, and we'll be done. Good to go. We can graph. So remember, the first step for the vertex is to take this equation and plug in with our values. So what am I going to plug in for B? I see. You were a step ahead. Okay. What am I going to plug in for my A? We're going to plug in 1. We will get to. Is that where you're at? So I know my x is -6 divided by 2 is -3. I know my x value is -3. Now, this is a point we're looking for. This step right here is finding the vertex. I know that at the bottom I'm going to have my vertex is equal to some point. The x component of that coordinate is -3. Remember, if you know one of the values, we know x is -3, we can plug it in to find the other value every time. So now I'm going to evaluate the original equation for f of -3. -3 squared plus 6 times -3 plus 5. See, I plugged in my -3 for my x values. This is probably the jump. This is the step. If you're not sure why we need to find anything else other than this -3 for x, it's because the coordinate has to have x and y for that vertex. Let's see what we can do with this. -3 squared is 9. -6 times -3, -18 plus 5. And go ahead and combine like terms there, or combine, simplify this. Combine terms. +9. +5, +14, -18. So you're on a diving board 14 feet above the water. You go down 18 feet.
-4.
-4. I know that there's other ways to look at that. I'm trying to get the conceptual part. All right, here we know our vertex. We're ready to graph. -3 for x, 1, 2, 3. -4 for y, 1, 2, 3, 4. Let's say right there. Now, I know that I have a line of symmetry, right? Oh, that's not where the point goes. It goes right here. I know that's my line of symmetry, right? The line of symmetry always goes through my vertex. So I know this. Follow me with this one. From the line of symmetry to this point that I know is on the graph, I have a certain distance, a -3 distance. Would you agree that if I go the same distance this way, I'm going to find another point? Does that make sense? Because the line of symmetry breaks it exactly in half. It's a mirror image. It's a mirror image on both sides. So because I have my vertex and I have my y-intercept, now I can go ahead and graph it from these points that I figured out. Isaac?
So the extreme is the y value.
Good. And it's negative?
-4.
-4. So the extrema is a minimum. You agree?
Yeah.
Cool. All right, good. So we're going to go ahead and make our graphs. Do you see that line of symmetry breaks up that parabola exactly the same on both sides? Not exactly, because it's hand drawn. Okay. All right. So what did we do? We looked at our original equation. A, B, and C were identified. We know that it opens up because A is positive. We put that here to remind us. We know that our C value is our y-intercept is 5, so I went ahead and put that on our graph. We found the vertex using the vertex formula, finding x, plugging into the original to find y. Put that point. We know the symmetry line goes through the vertex and it's going to be the same on both sides, so I figured out that this point over here is going to be the same distance, and now I have 3 points to draw my graph. All right, thumbs up, sideways, or down? A lot of thumbs up. All right, thumb sideways remember, classwork, you can work with your group. There's definitely thumbs up in every group, so help your neighbor out. Also, because this is honors, you want to get used to starting to use the calculator. I am going to, on my links, put the link to the TI-83 simulator. You can get online for free. Works exactly like a TI-83. If you have one of those, or if you have a Casio, it's going to be on you to start to learn how to graph these because you have so many different calculators in here. So it's going to be on you. Look in your manual or in the book. It goes over the instructions for TI-83. Try to start graphing these. I want you to at least try to graph the first like 3, okay, using the calculator. Make sure you can at least do 3 of them. Once you start and do it, it's going to be really quick. There is not going to be graphic calculators on the test though. So I just want to make sure you know how to do it, so when you get to calculus, you're not left behind there. But that's going to be on you. I'll help you if you need help. Sound good? All right, we're gonna do a subscription for all you watching out there.
Please subscribe.
Please subscribe. Subscribe on 3. 1, 2, 3.
Subscribe!
We gotta do that again. Subscribe on 3. 1, 2, 3.
Subscribe!